So in 5.2, we're going to look at what's called factoring trinomials. When we see the word tri in trinomials, that means that we're looking at things with now 3 terms. In the last section, we were mainly looking at things with 4 terms. Now, when we're dealing with 3 terms, we want them to be in what's called descending order. And by descending order, we mean how many x's they have in each piece. So notice this first piece had an x squared, which means 2 x's. Then it's going down in descending order 1x, and then notice the next piece has no x's. Just like the next example of a trinomial will have 2 x's first, 1x, and then notice that there's no x in front of the y squared in the last piece. That's what we mean by descending order with x's. It means the number of x's is always going down. You start out with 2, then 1, then none, most of the time. And then what we're going to use are the numbers out in front to factor. We've got an a will always be the number out in front of the first term, as long as it's in descending order. The b will be whatever's in front of the middle term, and the c will be whatever's in front of the last term, or kind of off by itself on the last term. So we'll have these a, b, and c's that we can determine, but it must be put in order first before you can figure out what your a, b, and c are. So this is going to be called AC method. And so that means is we're going to be worried about the A, the first value, and the C, the last value first before we do anything. So let's start out just by kind of forcing our way through an example. Let's start out with this first one here, this AX, so we've got x squared plus 6x plus 8. Now notice we're supposed to have an a B, and a C. I don't see any numbers in front of the x squared, so I don't know what my A is. But remember that there's always a hidden number out in front of every term. Even if you don't see something, it's a hidden 1. So our A is going to be a 1, and our C is an 8, and we'll use our B later. Notice the B has a plus sign out in front, so it's a positive 6. The C is also a positive 8. And the hidden 1 is always a positive 1. So the first thing that they want me to do in AC method is it's called AC because you're going to multiply A and C. So you'll start off by taking 1 times 8. The A was 1. The A was 1. So for A we'd use 1, and for C we had 8. So we do 1 times 8, which is 8. Now here's where we're going to use the number we haven't used yet, which is using the b. Now we want to break 8 up into 2 factors that add up to the b, the middle term, the b. So what 2 factors of 8 multiply together to give you 8 but add up to 6? Well, there's only 2 factors of 8 that actually give you 8 but add up to the middle number, the 6, and that's positive 2 and positive 4. Positive 2 and positive 4 do multiply together to give you 8, and 2 plus 4 also does add up together to give you the middle number, the 6, for the B. So the question is, what does that mean? Well, what we're going to do is we're going to break up our trinomial now. Our trinomial, or 3-piece thing that we were factoring, was an x squared plus 6x plus 8. And what we have to do is figure out how we're going to use this 2 and this 4 that we came up with. Well, what that 2 and 4 is going to let us do is break up this 6x. It's going to break up the 6x into 2 pieces. One that has a 2 and one that has a 4. So that's what we'll do. We'll break up the 6x into, they're both going to just break up into like terms, so it needs to be a 2x and a 4x. And again, they're adding up. They should both be positive because we want a positive 6x, so positive 2x and a positive 4x. The first term, the x squared, will stay the same. And the last term, the 8, stays the same. And you'd say, well, how does making more terms help me? But now, how many terms do we have? 1, 2, 3, 4 instead of 3. What did we do in the last section when we had 4 terms? Not 3. We did the factoring by grouping. We grouped the first 2, and we grouped the second 2. That's all we're going to do. Well, notice that what do the first 2 have in common? They both have a common factor of x. So we can factor out a common factor of x, which will leave us, well, the first one had 2 x's, so I'll still have an x left over. The second piece had a 2 and an x, so I'll still have the 2 left over. And I can carry down my plus that was in the middle. Now my second 2 have a 4x and an 8. They're both divisible by 4, so I can factor out a 4. Well, if I pull out the 4 from the first term, I'll still have the x. Pulling the 4 out of the 8 will still leave me with a 2. And just like in the last section, I know I am good because the x plus 2's match. Remember, I only have an issue if they don't match. So I can pull out the common factor, the matching factor of x plus 2. And then leftovers will go inside of their own parentheses. Well, the leftovers were an x plus 4. So there it is. My final answer, my factored answer, is an x plus 2 and an x plus 4. So the question becomes, why does this even work? It's because when you go to check your answer, you'll kind of see why. If you have your x plus 2 times your x plus 4, how do you check your answers? You FOIL. And how do you FOIL things out? Well, you start out by first multiplying out your x times your x, which will get you in x squared. Your x times your 4 gets you a 4x. Then your 2 times your x gets you a 2x. And the 2 times 4 gets you the 8. Notice, how many terms do you have? You have 4. And you've got 2 like terms in the middle. So what your AC method did is it helped you take what these terms end up being, which when you add them up end up being the 6x that we had. They help you go in reverse to break those terms up. That's why turning this into 4 terms actually helps, because it helps us go backwards to break down the 6x into the 4x and the 2x so that we can turn it into a grouping problem. So just as a quick summary of how this AC method works. So the AC method is only going to be used, the AC method is only going to be used when we're talking about doing 3 terms. It's got to be in descending order. And what it has to do with is you have to break up your middle term, so you'll have an ax squared plus bx plus c, is you'll use your a and your c to break this up into 2 pieces so that you'll end up with, when you're all said and done, something with 4 terms. And then on those 4 terms, you can do grouping. You can do factor by grouping on the 4 terms. So AC method is kind of a new thing, but it just turns it into something else we already know how to do, the factoring by grouping. And so this means, remember, the factoring by grouping is based on finding what they have in common. So I would say probably 80% of all of our factoring is going to have to do with finding something in common. Whether it's between all the terms or turning it into a grouping problem like we're doing this here, or if you actually already have 4 terms so you're doing grouping, that's what we're going to be doing about 80% of the time.